Hello everybody, welcome into another lesson. So today we are going to talk about geometric sequences. So the past couple lessons were devoted to arithmetic sequences in series, where in arithmetic sequences in series you have a common difference between terms. So geometric sequences differ in the fact that there's a common ratio between terms. Instead of adding numbers between terms and having that same common difference, in the geometric sequence, you have the same common multiple between each term, such as a common ratio. And if it's a geometric sequence, the formula for the nth term, the explicit formula for a geometric sequence is a sub n equals your a sub 1 term, your first term, times your common ratio to the n minus 1 power. So let's look at some examples here. So we have this geometric sequence 5, 15, 45, 135. And then it just keeps on going. But if you look between each term, between 5 and 15, if you multiply 5 times 3, you get 15. 15 times 3, you get 45. 45 times 3, you get 135, and so on. So that times 3, that's your common ratio. So you're going to say that R equals 3. So your common ratio is 3. Your a sub 1 term is going to be that first term, which is 5. So in some ways, geometric sequences are probably the easiest to find an explicit formula for. In this case, the formula would be a sub n equals that a sub 1, which is 5, times your common ratio, which is 3, to the n minus 1 power. And we can test it for a couple terms. Let's say I put in n being 1. Well, 1 minus 1 is 0, 3 to the 0 power is 1, and 5 times 1 is 5. Now if I put in 2 for n, I will get 2 minus 1, which is 1. 3 to the first power is 3, times that 5 is 15. Then if I put in 3 for n, I'll get 3 minus 1, which is 2. Well, 3 to the second is 9, times that 5 is 45. So we see this formula holds. So the formula for this particular geometric sequence is going to be a sub n equals 5 times 3 to the n minus 1. And I got plenty more. Alright, we have 3, 12, 48, 192, and it just keeps on going and going. So first we need to determine, is this a geometric sequence? Well, between 3 and 12 you have to multiply by 4. Between 12 and 48 you multiply by 4. And between 48 and 192 you multiply by 4. And this pattern seems to hold, so yes, this is a geometric sequence. You have the same common ratio of 4. You multiply by 4 between each of the numbers, so that's your common ratio. Your a sub 1 term, your first term, would be 3. So now we have enough information to go ahead and get the explicit formula for the nth term of the sequence. So a sub n would equal our a sub 1, which is 3, times our common ratio of 4 to the n minus 1 power. So a sub n, the explicit formula for the nth term, would be 3 times the quantity of 4 to the n minus 1 power. Alright, let's see. Now, what if we gave you something like this? You have 6, 18, 30, 42, and then it keeps on going and going. Well, is this a geometric sequence? So 6 times 3 is 18. Well, 18 doesn't go into 30 evenly. 30 doesn't go into 42 evenly. This is definitely not geometric. This is not a geometric sequence at all. It would in fact be arithmetic because they have the same common difference, but they don't have the same common ratio. So this is not geometric, but it is arithmetic, but it wasn't asking if it was arithmetic. It was just asking if it was geometric, and it's definitely not. Now, this is a good one. So you have 1, -2, +4, -8, and it just keeps on going and going. So you have 1, -2, +4, -8, it keeps on going and going. This is definitely an alternating sequence, but is it geometric also? Well, 1 times -2 equals -2, -2 times -2 equals +4, and then 4 times -2 equals -8. So actually, yes, this is geometric because you have the same common multiple of -2 between each of the terms. So your common ratio is going to be -2. Now your a sub 1 term is 1. Alright, so we can write this formula as a sub n equals, and you could put that 1 in the formula, but 1 times anything is itself, right? If your first term is 1, you don't actually need to write it. You could just go right to your common ratio of that -2 to the n minus 1. So a sub n would equal that -2 to the n minus 1 power. Alright, let's see. We have 1, -1/2, +1/4, -1/8, and it just keeps on going and going and going. So this sequence is 1, -1/2, +1/4, -1/8. It keeps on going and going. Well, is this a geometric sequence? Well, to get from 1 to -1/2, you multiply by -1/2. To get from -1/2 to -1 to +1/4, you multiply by another -1/2. Then to get to 1/4, to get from 1/4 to -1/8, you multiply by another -1/2. So actually, this is geometric. You have the same common ratio of -1/2. And yes, you can have fractions and decimals as your common ratio. You could even have roots. As long as it has the same common multiple between terms, it's going to be geometric. Now your a sub 1 is 1. So now we have enough to find the explicit formula for the nth term of the sequence. A sub n would just equal that -1/2 to the n minus 1 power. So a sub n equals -1/2 to the n minus 1 power. That's what you would end up getting. Alright, so that's very basic, given taking terms of a sequence and finding the explicit formula. Now, we are going to find the nth term of a sequence if we're given a couple of terms. And yeah, if we're given a couple of terms here, and then we're going to also find a specific term. So in this case, we're going to start out given the first term and another term. So a sub 1 equals 4 a sub 4 equals 1/2. Well, okay, so first thing we want to do, if we're just given two terms of a sequence, we definitely want to find the common ratio so we can find the explicit formula for the nth term of the sequence. And then we can find whatever term we want. So this is very similar to what we did yesterday when we talked about arithmetic sequences and we were given terms and we had to try to solve for the common difference and all that. Well, instead of that, today with geometric sequences, we're going to solve for the common ratio. So we know the first term. We can actually substitute that into the formula for the fourth term. So we could say a sub 4, taking this a sub n formula, equals a sub 1 times our common ratio to the n minus 1, all right? Well, a sub 4 in this case is going to be 1/2. That's going to equal my a sub 1, which is 4, times r to the n minus 1 power. Alright, so we've done the substitution. Now, what we need to do is ultimately we have to solve for r. This is where it's going to get fun. We can isolate r by itself by dividing both sides by 4. If we do that, we get r to the n minus 1 power equals 1/8. Well, how the heck are we going to solve for r? You know what? I should have said, hold on one second, I see what I did. If it's the fourth term, it should be r to the 4 minus... It should be r to the 4 minus 1, which would be 4r to the third. There we go. I see what I did. I forgot to put in that 4 for r. Okay. So we would have r to the third equals 1/8. Now we just take the cube root of both sides. You'll have that r equals 1/2. So you got a common ratio of 1/2. Now we can find the explicit formula for the sequence. That's going to be a sub n equals my first term, that a sub 1, which is 4, times my common ratio of 1/2 to the n minus 1 power. So there's my term for the sequence. Now, they would like for us to find the they would like for us to find the 10th term. So let's find a sub 10. That's going to end up equaling 4 times 1/2 to the 10 minus 1, which would equal 4 times 1/2 to the 9th, which would be 4 times some really big denominator, of course. We're going to have a big denominator, so let's figure out what 2 to the 9th is. That's going to be 4 times 1 over 512, which we should be able to get a final answer here for 512 divided by 4. This would simplify into 1 over 128. So the 10th term of this sequence is going to be 1 over 128. Once you find the explicit general formula, you can find any term you wish using that. Let's do another one like this. Alright, so a sub 1 equals 5. A sub 3 equals 45/4. You can already tell this is not going to be pretty, but it is what it is. So a sub 1 equals 5, a sub 3 equals 45/4. Well, good news is we're already given a sub 1. We just need to substitute that in for a sub 3 and solve for the ratio. So let's set up our a sub 3. That means a sub 3, based on this formula, is going to be our a sub 1 times our common ratio of to the n minus 1 power, in this case to the 3 minus 1 power. Well, let's see. So a sub 3 was determined to be 45/4. That's going to equal my a sub 1, which is 5, times my common ratio to the second power. Well, now we just need to solve for r. So we'll get r squared if we divide both sides by 5. R squared equals 9/4, which means r would equal either plus or minus 3/2. Here's the thing. It could be either plus or minus 3/2 because we don't know what the second term is. We don't know if it's positive or negative. So it is entirely possible to have two values of r. It's entirely possible. So that means in this case we're going to have two explicit formulas. So a sub n equals our a sub 1, which is 5. Now let's go based on the positive 3/2 first, times that 3/2 to the n minus 1 power. That is one possible formula. The other possibility is when you have the common ratio being negative 3/2. A sub n would equal 5 times negative 3/2 to the n minus 1 power. And then they want us to find the eighth term. They want us to take when n equals 8. So that means we're going to have two possibilities for the eighth term. So a sub n would equal 5, or a sub 8 I should say, we're finding the eighth term, would equal 5 times 3/2 to the 8 minus 1 power, which would equal 5 times 3/2 to the 7th power, which would equal 5 times whatever the heck that is. All right, 2,187 all over 128. Which I'm not sure if 2,187 and 128 have any common factors. They don't appear to, so it's just going to be awful. So that means the eighth term is going to end up being 10,935 over 128 based on a common ratio that's positive 3/2. Or if we try to put it into this particular formula with the negative common ratio, all you have to do is take that 5 times that negative 3/2 to the 8 minus 1 power, which would give you 5 times negative 3/2 to the 7th power, Since it's an odd power, that means you'll get a negative quantity. So this would be 5 times negative 2,187 over 128, which would give you negative 10,935 over 128. So you have two possibilities for the nth term of the sequence for the formula for that, and that also means as a result you have two possibilities for the 8th term of the sequence, depending upon which common ratio you use. So that's something to keep in mind here. Let's do one more where we're given the first term, and then we'll spice it up a bit with other terms. All right. We have a sub 1 equals 6. Let's see, let's do a sub 5 equals 18. Yeah. So a sub 1 equals 6, a sub 5 equals 18. Alright, so we at least know a sub 1, then we know the 5th term. Alright, what we don't know yet's the common ratio, but knowing a sub 1 is going to help us find the common ratio, so we can take this formula for a sub 5. So that means a sub 5 equals my a sub 1 times my common ratio to the 5 minus 1 power. Well, a sub 5 was defined to be 18. That's going to equal my a sub 1, which is 6, times my common ratio to the 4th power. Alright, so my common ratio, if I want to solve for that r, we're going to have r to the 4th would equal 3. That simply means that r, since we have an even root, r is going to equal plus and minus the 4th root of 3. And you can have a common ratio of roots. That is possible. So you have two possible common ratios of positive and negative the 4th root of 3. And some of these sequences are not pretty. But now that we know the common ratio, we have a hope of finding the explicit formula. So let's go ahead and do that. Since we have two common ratios, we're going to have two explicit formulas. So let's go based on the positive 4th root first. So a sub n is going to equal my a sub 1, which is 6, times my positive 4th root of 3 raised to the n minus 1 power. So there's for the positive common ratio. We also have a negative common ratio. We can take a sub n equals 6 times that negative 4th root of 3 raised to the n minus 1 power. So those are the two possible formulas for the nth term of the sequence. We're going to work backwards. We're going to find the second term of the sequence. So let's just take n equals 2. Let's find the second term. So that if we want to use the positive common ratio formula, a sub 2 is going to equal my a sub 1, which is 6, times that fourth root of 3 raised to the 2 minus 1 power, which would equal 6 times that fourth root of 3 raised to the 1 power, which would just end up giving me 6 times the fourth root of 3. So that means my second term has one possibility of positive 6 times the fourth root of 3. And then that means we have another possibility for the second term if we use the negative common ratio. So a sub 2 would equal 6 times my negative fourth root of 3 raised to the 2 minus 1 power, which would give me 6 times my negative fourth root of 3 raised to the first power, which would just give me negative 6 times the fourth root of 3. So, based on having two common ratios, I have two possible formulas for the nth term of the sequence, and then, as a result, two possibilities for the second term of the sequence. Alright, let's change it now. Let's say we're not even given the first term. We're going to be given some other terms. What if we are given the second term? So a sub 2 equals negative 18. A sub 5 equals 2/3. So all of a sudden we don't even have the first term. So this is largely going to seem like a system of equations again. So let's take the formula here, the general formula for a geometric sequence for each term. That means a sub 2 would equal a sub 1 times our common ratio to the 2 minus 1 power, which we know a sub 2 to be negative 18. That's going to equal a sub 1, and then 2 minus 1 is 1. That would just be a sub 1 times r. And then we have the a sub 5 we need to figure out. So a sub 5 is going to equal a sub 1 times r to the 5 minus 1 power, which means that since a sub 5 is 2/3, so 2/3 would equal a sub 1 times r to the 4th. Alright, well, what I am going to suggest here, so let's set up this system. You have a sub 1 times r equals negative 18. You have a sub 1 times r to the 4th equals 2/3. What I'm going to suggest is you do a substitution by solving for a sub 1 in the first equation. Okay, so if you take your a sub 1 times r equals negative 18, if you want to solve for a sub 1, that means a sub 1 is going to equal negative 18 divided by r. Why is that important? Well, it'll become more apparent when we put it into the second equation. If we substitute that negative 18 times r in for a sub 1 in the second equation, you'll have negative 18 times r times your r to the 4th is equal to 2/3. Okay, so that means you're going to have an r cancel out. You'll just have negative 18 r to the 3rd equals 2/3. Now we just want to get that r to the 3rd by itself, so r to the third is going to equal 2/3 divided by negative 18, well, that's going to end up being negative 1/27 when you simplify it. And we can take an even cube root of negative 1/27. Our common ratio would just equal negative 1/3. So now we've identified our common ratio to be negative 1/3, so all I have to do to solve for my a sub 1 is put that into the substitution formula. So a sub 1 would equal negative 18 divided by my negative 1/3. Complex fraction will invert and multiply. That'd be negative 18 over positive 1 times 3 over negative 1. Well, my negatives are going to cancel out, so that's just simply going to give me then 54. That means my first term is going to be positive 54. Now we have a hope of finding the nth term of this, finding the formula for the nth term of the sequence. We know both the a sub 1 and the common ratio. So the formula for the nth term of the sequence is going to be my a sub 1, which is 54, times my common ratio of negative 1/3 to the n minus 1 power. So there's my formula for the nth term of the sequence. A sub n equals 54 times negative 1/3 to the n minus 1 power. And let's say they want us to find the sixth term. We're going to find the sixth term of this sequence. So a sub 6 is going to equal 54 times negative 1/3 to the 6 minus 1 power, which is going to equal 54 times negative 1/3 to the 5th power, which is going to equal 54 times negative 1 over 243, which we can simplify this then into 2 times negative 1 over, let's see, negative 1 over 9, which should end up giving me negative 2/9. So that means the sixth term should end up being negative 2/9 if I put that into the sequence. Let's do one more, then we'll be done with this lesson. Alright, we're given the third term, a sub 3, which is 16/3, a sub 5 is 64/27. So we know the third term and we know the fifth term. We don't know the first term, we don't know the common ratio. So that means for each of these terms we need to set up this general formula. So let's start with the third term. That means a sub 3 is going to equal my a sub 1 times my common ratio to the 3 minus 1 power. Well, a sub 3 was determined to be 16/3. That would equal my a sub 1 times r to the second power. Now we need to set up this formula for a sub 5. So a sub 5 is going to equal my a sub 1 times r to the 5 minus 1 power. Well, a sub 5 was defined to be 64/27. That would mean that equals a sub 1 times r to the 4th power. So now we have two formulas where we don't know a sub 1 or the ratio, but what I would highly suggest is we solve for a sub 1 with the smaller root, with the smaller r. Take the smaller power of r and solve for a sub 1. So that means a sub 1 would equal 16 over 3r squared. That is going to come in handy because now we can substitute it into this side. So that we could say 64/27 equals my a sub 1. Substitute that 16 over 3r squared in. Equals 16 over 3r squared times r to the 4th. Well, that means 64. Actually, let's reverse this order here. That means the r's will cancel out between each other, so you'll end up having 16/3 r to the 2nd equals 64/27. So 16r squared equals 64/9. So r squared equals 4/9. Now we just have a simple quadratic. We're going to have two possible values for our common ratio. So take the positive and negative square root of 4/9. That means r is going to equal plus and minus 2/3. Alright, so we got that. Now, we need to find the a sub 1 formula. So, we got our common ratio. We can substitute this into a sub 1 and solve for a sub 1. So, a sub 1 is going to equal 16 over 3 times my common ratio squared. Well, good news is, though we have two common ratios, whether it's positive or negative, since we're squaring that ratio, it's going to be positive. So 3 times, we'll say 2/3 squared equals 16 over 3 times 4/9, which is going to equal 16 over 3 times, oh, that'd be 16 over 4/3, which would end up giving me 16 over 1 times 3/4, which would turn into 12. So now we know that a sub 1 is 12, and then my common ratios are both positive and negative 2/3. So let's find the explicit formulas for this sequence, simply for the fact that we have two common ratios. So a sub n for the positive common ratio of 2/3 is going to equal my a sub 1, which is 12, times my common ratio of positive 2/3 to the n minus 1 power. That's for your positive. Now, you also have a possibility with a negative common ratio, so a sub n would equal 12 times negative 2/3 to the n minus 1. And then from there, you could find whatever term of the sequence you want. But we have two formulas because you have two common ratios. Alright, so that's it for this lesson. In the next lesson, we're going to get into geometric series. So I hope everyone has a great day. Take care.